just open this one. Up next, we have Taniah Chifumro, and she will be talking about automatic sorting machine for construction and demolition waste recycling. Over to you, Taniah.
Well, thank you for the time to present my project. Let me try to share my screen. Can you guys all see my screen? Okay, thank you. Okay, my focus is on developing an automatic sorting machine for construction and demolition waste cycle. Due to the rapid development of engineering, construction, and housing industry, the output of construction waste is increasing at a very high speed, and the proportion to challenges such as insufficient data for model training and limited interpretability of AI models continue to persist. One of the biggest generators of solid waste globally comes from the construction industry. Construction and demolition waste are defined as the excess material generated during construction and demolition processes. And the examples, they include concrete, bricks, steel, glass, wood, plastics, rubble, etc. And the construction and demolition waste, they account for about 25% to 30% of the total waste generated worldwide. And in Australia, it has been noted that it accounts for about 44%. In a brief period of time, I'll explain the following topics and the rationale for why this research is important. Here, we considered a novel approach that promises to enhance, firstly, the waste management challenges, as it has been found that the manual sorting methods, which are often inefficient, labor-intensive, and costly, they lead to inadequate waste separation. So by having this automatic sorting machine, we'll be able to elude all the waste management challenges. Secondly, the environmental impacts. The construction and the demolition waste, they have significant environmental impacts. For example, they cause land degradation, groundwater contamination, land and air pollution, and also the greenhouse gas emissions, which contribute to climate change. So by having this automatic sorting machine, we'll be able to eradicate all the environmental impacts. And thirdly, we have the economical benefits that are brought by this automatic sorting machine. It will be able to increase the recycling rates, it will reduce the disposal costs, and also it will be able to generate revenue from recovering valuable materials. Due to the lack of disposal sites and the limitation of natural resources, the construction and the demolition waste has attracted considerable attention. Here on this pie chart, we have the average composition of the construction and the demolition waste, with 30% of wood, which comes as extra material, 5% plastics, 26% we have concrete and bricks, 10% metal, 13% from roofing, 13% also, these include limestones, gravel, sandstone, and 3% cardboard or paper. This research's aim was to convey the importance of developing an automatic sorting machine for construction and demolition waste. Consequently, using the artificial intelligence in waste logistics, we can be able to reduce the transportation distance by up to 36.8%, cost savings by up to 13.35%, and we can save time by up to 28.22%. And also by having this automatic sorting machine, we'll be able to reduce the landfill waste and stop the waste treatment processes, which is called incinerating, which contributes to air pollution by producing flue gas emissions. And also we can reduce the piling up of our waste on our natural resources. The objectives of these projects are to develop an efficient and an accurate automatic sorting system for construction and the demolition waste, and also will be able to improve the waste management in construction industry. The most important is to introduce the on-site recycling, as it has been found that it is very extreme difficult to do the recycling on-site. And we'll be able also to reduce our waste disposal costs and conserve our resources, and also we'll be able to reduce intense human labor. To ensure the validity and the reliability of our numerical work, we will carefully consider the best AI tool, which is as it has been found that the machine learning models, they primarily operate with numerical data, while for the construction and the demolition waste, which generally involves the construction type, the project size, the location and also the disposal methods and the disposal regulations. So here we have found that the construction waste recycling technology is still in its infancy. So by developing a software, an AI that will be able to eradicate these problems, and will be able to have data for waste management. And secondly, here we have the robots in our device. The robots will work hand in hand with the AI or the software, and the robots will perform physical tasks. So the AI will be the brain of this device, the robots will be the muscles, and thirdly, the material type. The construction and the demolition waste have varied 3D shapes, which makes it hard for robot manipulations. And as of the past decades, the present automatic sorting machine, they are able to only grasp only 2D shapes. But here we'll develop an automatic sorting machine that will be able to grasp both 2D and 3D shapes. The block diagram for our automatic sorting machine will involve a conveyor run. This one will involve the light-duty conveyor belt with a 12 VDC motor and rollers and belts. And the main sensors that we're going to use here are the infrared sensors, which are going to sense objects. These ones, they work by emitting light, which encounters an object, as you can see here. The sensor then measures the intensity and the characteristics of the reflected light to determine the presence and sometimes the distance of the reflected object. So once this IR senses an object, it then moves it to the magnets. The magnet will create a magnetic field to attract all the metallic waste from the construction and the demolition activities. And the remaining waste is going to be taken to the hopper. This one will take all the non-metals like the concrete, the plastics, the bricks, and then they are going to be grouped in group 2 as the non-metals, and we have group 1 as the metals. So the overall process here, we have the multi-sensory unit, the processing unit with the AI, the learning-based action task, and also our robot controller. The expected results here, we expect to have digitalization in the construction industry, and most importantly, to have the innovative 3D localization techniques, and also to reduce the waste management costs. In summary, the implementation of an automatic sorting machine for construction and demolition waste cycle management will contribute to the reduction of pollution factors and also mitigate the climate change challenges. Here are the references that I use. Thank you for your attention. I'll open the platform for questions or any contributions. Thank you.
It's me, sorry. Can I, do you want to contribute or have a question, Sophia? I'll go after you.
I was just going to say it's so it's so good because you're right with how much, like, even just I noticed like how much just gets thrown away that could definitely be reused or recycled. So it's such a necessary thing. I was just wondering, have you already started like with these robots, like and making these sorting machines, and have you already started doing?
As of recent, I haven't started. I was only working on the literature review and the background analysis. I haven't started working on the robots, but I'm just working on learning the AI softwares and the best AI software. So I'm studying the best AI software like the Sidewinder, the Build Start, and also the HiCAD.
Cool. All right. It's really good.
Thank you.
Yeah. So it's a huge industry, like Sofian said, Taniah, here, especially in Australia. It's a big challenge, and I think there's big money being invested in this industry. There's a large company called Bingo in Australia doing construction and demolition waste recycling, but it's all being done manual. And you can't just imagine what's the staff turnover is look like. But backing to your presentation, about 26% of concrete of the C&D waste is concrete and 30% is wood. Well, it depends on the reference and the location, obviously, but as just a bit of a contribution, I think if we neglect other components of the waste and just focused on concrete and wood, it would cover 56% of the waste, which is pretty huge again. So that's one contribution. Another question I had actually was that, are these sensors capable of determining or understanding the density of the material? I mean, imagine there's a sensor on a conveyor. How does that infrared sensor is going to distinguish whether that object in front of it is a concrete or is a wood? Like what are the, yeah.
Okay. As for the infrared sensor, it only detects an object. It is unable to detect whether it's concrete or wood. That's why we will have the magnets that will be able to attract all the metallic waste. And also, I was thinking of the induction sensor, but this one, it is a little bit costly and it requires electricity.
What is an induction sensor?
This one, I didn't include it, but I just came across it when I was doing my research. This one, as I mentioned, it requires electricity, and also it will be able to separate metals and non-metals. That is main aim, to separate metals and non-metals from the waste.
There was a research topic. It's really relevant to what I've done during my PhD studies. That's why I'm really interested in your topic. There was a paper talking about having cameras and object detection algorithms to distinguish between each waste particle. But the problem that paper came up with was that sometimes, because it's waste, most of the time the color is the same. But if the material was new, well, the camera would be able to detect, I mean, distinguish between the color of a concrete and the color of a wood. So yeah, maybe camera and object detection can be something that you can go ahead with as well. That's all. Thank you.
Okay, thank you so much. Okay, thank you. Over to you, Sophia.
Thank you, Taniah. All right, so up next we have Franklin Nusu, and he'll be talking about AI integration in estimating construction.